Hello, my name is Rajbir Singh, and I have chosen topic Zigbee technology in IoT for my seminar CS900. And these are the topics I'm going to cover in the next slides. First one is Internet of Things, need of IoT, fundamental components of IoT, Zigbee technology, practical demonstration, hardware specifications, connecting sensor board to VAS mode, soil temperature sensor, connecting VAS mode to another VAS mode using Zigbee technology. This one is the practical demonstration of Zigbee technology and recent work using Zigbee technology. Internet of Things. It is defined as the network of connectivity of devices like home appliances and vehicles that allow exchanging the data. Anything where we need to exchange data is comes under the Internet of Things, especially where we use sensors and the other small devices. It has significant heated topic in business and trade. Therefore, the things in the Internet of Things can be represented the sensor or the devices that transfer the data over the network. So things means sensors or the small devices we use to create a network in order to transfer the data. Why we need of IoT? IoT assists in business operations by providing the real-time look into the organization systems. It is the most widely used technology in the field of health care where which monitors the blood pressure, pulse rate, etc. We have the small devices to measure pulse rate or the blood pressure which comes under the IoT. IoT reduces the human efforts by evolving the smart homes. Like we have a smart home automation systems, like doors open automatically when we need to park our car, especially the garage one. We have a button, we just click the button and the car garage door automatically opens and we can park our cars. It helps the people in order to reduce the waste and energy consumption, which is known as smart cities. So it has a significant role in a smart cities. It plays a significant role in the field of IoT, which helps in measuring the soil fertility along with the moisture and temperature. So it has a significant role in agriculture also. Like if we monitor the temperature and pressure of soil, then we can increase the yield of crop because all these factors helps to monitor the agriculture properly. Fundamental components of IoT. Devices or sensors. These are the fundamental components which are responsible to collect the real-time data from the environment. These are present at the edge layer. So IoT has three layers: edge layer, fog layer, and cloud layer. All the sensors are on the edge layer, like the physical layer, like we have a physical layer in the other networks. So here we have a edge layer. Connectivity. The connected data from sensors is sent to other devices by means of Zigbee gateway or Wi-Fi. So we need to collect that data and send to over the network. We need something like a gateway. So we are using here Zigbee gateway. Data processing. At the cloud level, the collected undergoes processing or analysis that can be performed by the software. The processed data can be reflected in the form of sensor reading like temperature reading. So data processing is done at the fog layer and cloud level both. Data processing means we need to analyze the data. So only the crucial data we send to cloud, not all the data. So like the one sensor sends the reading of temperature, we just need to figure out which reading should be goes to cloud. So only that reading will be go to cloud, not all the readings. Next one is user interface. It is the interface which notifies the user about the actions performed by the sensors. It can be a text messages, alarms, or emails. So user interface. Supposingly, if we want to know the temperature of a room, so like we have working ACs, we set our temperature to a particular value. When that temperature reaches, then the AC automatically stops or yeah. Next one is Zigbee technology. It is a wireless technology evolved as an open global standard which is used to create low cost and low power networks in IoT. It is implemented on the physical and MAC layer of IEEE 802.15.4. IEEE is Institute of Electrical and Electronics Engineers. This is the basic standard for IoT. So this one is the first one when IoT starts rising. So IEEE 802.15.4 standard is the basic standard, and Zigbee technology uses physical and MAC layer of this standard. The network layer of Zigbee stack is responsible for selecting appropriate topology for the network. Here, the work of network and security layer is to select the topology. For security purposes, Zigbee utilizes 802.15.4 for security at the MAC layer, which uses advanced encryption standard with the 128-bit key value. So, for the security purposes, Zigbee uses the advanced encryption standard with 128-bit key algorithm. It provides security at the network and application layer. Zigbee is one of the most well-known protocols built on the IEEE 802.15.4 foundation. So this one is the one of the well-known protocol or technology well-known after IEEE 802.15.4. Home automation, smart energy, and smart agriculture are three examples which uses Zigbee technology. So these are the main three examples. Practical demonstration. So here we will I'm going to show how actually Zigbee technology works. So I have chosen smart agriculture topic. So in the field of agriculture, the production of crop can be enhanced by measuring the temperature, moisture, and humidity level in the soil. The fertility of the soil can be monitored in order to increase the yield of the crop. If we know all these factors, then automatically we can increase the yield of the crop. The temperature of the soil can be measured by using the Zigbee technology with vast mode device. So here we need vast mode devices to using the Zigbee technology in order to get the temperature readings. Hardware specifications. These are the hardwares we need to perform this experiment. First one is vast mode Pro V1.5. Second one, agriculture sensor board V3. Third one is temperature sensor PT1000 and Zigbee as a gateway and a mini USB cable. So actually I have chosen this topic because I have done one practical demonstration in our course IoT Internet of Things. So we need all these devices to perform the experiment. We need to connect sensor board to VAS mode. VAS mode is like a small devices, like we can say small computer device. So the connectivity of the sensor board with the VAS mode involves the following steps. Zigbee is connected with the VAS mode in the Zigbee socket. Then the sensor board is connected to the VAS mode, and the sensor are attached to the sensor board at their respective sockets. And the connectivity of VAS mode Pro with agriculture sensor board is shown in figure 2. So here the lower one here is the VAS mode. This one is the VAS mode device, and this one is the agriculture sensor board, and we connected sensors here in the agriculture sensor board on a particular socket, like they are mentioned where the actual sensor goes on a agriculture sensor board. So this one is the real pic when I was performing the experiment in IoT class. Soil temperature sensor PT1000. It is the most commonly used sensor in the field of agriculture, which has the variable resistance from 920 ohms to 1200 ohms. Due to low variable range of resistance of the sensor, it results in very low variations of the voltage at tremendous changes of temperature. So these are the specifications of the sensor PT1000, and the temperature value is measured in Celsius degree by using the function of the library read PT1000. So actually the VAS mode IDE has some inbuilt functions to capture the readings of the sensors. So this one is the function name to capture the readings. I will show like in coming slides how we actually perform the code in order to get the readings. So we need a IDE, a VAS mode IDE for the coding purposes. Soil temperature sensor. The PT1000 soil temperature sensor has a measurement range from minus 50 to 300 degrees Celsius, and it has 1000 ohm of resistance. So these are the main specifications of soil temperature sensor. This one is the VAS Mode IDE, VAS Mode Pro IDE. This is the actually the framework where we run code to get readings from the sensor and send that readings from one VAS mode to another VAS mode. So this is the product of the Labellium website. So Labellium is a big company of IoT which usually make products for IoT. So this one is the product of Labellium. And here is the program to send packet from one VAS mode to another VAS mode. It has the same pattern like the other programming language. Like we need to include libraries here. Like here, we added VAS mode Zigbee.h. These are all the libraries from which we need to get data from the sensors. So this is the code to get data from the sensors and send it to other VAS mode through a Zigbee technology. So this one is like the programming software to run IDE code. So here is the MAC address of the destination VAS mode, like where we want to send the readings. So this one is the destination address, and here is the node of that VAS mode, which we can get by using the XCTU. I will explain later in the coming slides. And this program is for sending packet example, and the main function is like here we can get here is the PT1000 class, which has object of PT1000 sensor, and we can use function read PT of this class. So by using this class function read PT, we can get the sensor values in a variable value, and we will send this value to another VAS mode in the form of a frame set. So here is the like send on other Zigbee. We can use a Zigbee function dot send function of a Zigbee class. So here is we need a address, frame buffer, and frame length. So if there is a send OK, it means frame is send successfully, and if there is an error in sending frame, then it will show send error. So I will show you the output of this program and the sender's program and the receiver's program in coming slides. And these are all the parameters we need to connect with the other VAS mode, like 64-bit PAN. And here we like it will print join a network when everything like goes well. Network will be established between two VAS modes. Connecting temperature sensor. The PT1000 temperature sensor has two slots to plug in into on agriculture sensor board. One part is plugged into temperature slot and the other part is plugged in at grounded slot. So here is the image of the socket where we need to insert the sensor leads. Connecting one VAS mode with another VAS mode using Zigbee technology. This includes the communication between two VAS modes. In order to create network between two VAS modes, we need to configure the Zigbee radio modules so that we can use the MAC address and node ID of the Zigbee. It requires the following steps. Configure the Zigbee using XCTU interface and sending packets from sender to receiver using VAS Mode IDE. So here VAS Mode IDE is the programming software where we will actually code to send data from one VAS mode to another VAS mode, and we need a MAC address and node ID of the other VAS mode where we actually needs to send the data. So here is the image of configuration of Zigbee of using XCTU interface. So this one is the XCTU interface where we search for the devices, and we search the VAS mode with MAC address of this one. Like 0013A20041EA6AF. So this one is the MAC address of Zigbee where we need to send the data. And we search these devices by using the XCTU interface. Here is the second picture of the Zigbee of using XCTU interface. Like we find this device, how we need to configure this device in order to send the data. So we need to add the These are the configuration we need to set in order to send the data. How to get sensor readings via Wasmod IDE. This is the IDE. Like this is the picture of IDE temperature sensor readings. After running the code, we get the output as this one. Like here is the PT1000 temperature sensor reading. This is the reading of the sensor. Send OK. Send OK means the readings are successfully sent to other WAS mode. And this one is the screenshot of the receiving end, how the other was mode receiving the readings. So here is the temperature reading 26, and sorry, temperature reading 26. So this one is the screenshot of the receiver's end. And here is some other parameters like length of the data that we all need to set in the WAS mode configurations. Recent work using Zigbee technology. Like International CES Las Vegas in Jan 2019, D-Link announced their new DCS8330LH Full HD Wi-Fi camera and new MyD-Link devices with Zigbee technology. So recently in 2019, still we are using the Zigbee technology, especially in the IoT. And with the MyD-Link app, user can receive alerts from the MyD-Link sensor and the trigger automation like recording video clips to the cloud and turning lights on with the MyD-Link smart plug. So when there is any sensor triggers, it automatically start recording the video and send it to the cloud and turning lights on by using smart plug. And this one also supports intelligent video analytics features such as moving objects detection and human detection to reduce false alarms. Like if there is a human detection, only then alarm should be generated, not on other objects. So this one is the important function of the new camera. So here is the source where I get to know about all these things. Thank you. And if you guys have any question, please send me an email. I will mention or you can also send me on a UR course.